Okay guys, today's video is going to be on doing a P25 receiver test on an M150 mobile BK radio, and I'm going to go through the setup on the R2625 communications monitor here, and show you how to check the voice as well as do a bit error rate test. I want to start off with just a display of, I want to kind of go over the different parts of the screen here. We're currently generating a signal at -90 dBm, and we're on a 1512875, and I currently have the thing set up to do voice. And if I go to my microphone here and I key up and test 1 2 3 4, I'm not hearing anything coming out of my radio, and I wanted to show you how this works before I go into the display. But if you look up here at my radio, you'll see it's getting a good signal, and you see the busy light there, but it's not passing any audio. And the reason is because I'm generating the wrong NAC code right now. The radio is programmed to receive on NAC 293, but I'm generating NAC 294, and I'm about to go in to show you where to change that. But before I do, I wanted to show you how and especially if you're a radio tech, you should have your channel programmed for NAC code F7E, which is kind of like carrier squelch in the analog world. It'll let any NAC come through. And as you see on my display, I also have it alternating between unit ID and the NAC ID of what's coming in. And so you're seeing right now I'm generating 294, and if I get on my microphone, testing 1 2 3 4, it's working. So now if I go back to the 293 channel, once again I'm muted out because I don't have the right NAC. Now if I try and go into the screen right now to do the display table and change it, it'll bonk at me. I want to show you, so I'll go to, and it gives you a little warning saying entry field must be mode with mod off first. So you got to get back here, and you got to turn the deviation off. Then you can go back into the display table and set your NAC code to the one you want. So we'll go 293, and now we can go return and go back up here and turn it back on. And now testing 1 2 3 4, we're working, and you can see I get a good decode there, and it is showing me my NAC code coming in. So this would be kind of like your initial setup, to where you want to just make sure your monitor is operating properly in P25 mode, and that you're generating and your voice and everything is operating. I want the audio down here. This is where your microphone, your voice level is set. Testing 1 2 3 4, and you can adjust how loud or quiet your microphone is at that point there. It also has a fixed 1 kilohertz tone that's not too pleasant, and it's kind of cutty. It's not as good as the other test tone that they have here, so I pretty much don't bother with it. But anyway, here's your kind of standard setup. Now we're ready to actually do a bit error rate test. And what's going to happen here is that when I go into the bit error rate test here, I'm going to use this 1011 pattern, and I'm going to come over here to my my NeoVision that's hooked up to the BK radio here, and I'll start the receive test. And what's going to happen is my service monitor is going to send a pattern of zeros and ones, and the radio is going to already have that pattern stored in its memory, and it's going to compare what's coming in with what it has stored, and it'll see if there's any errors between the two, and it'll give you a percentage of how much errors, and we're going to adjust until we get a 5% error rate, and that'll be our essentially like our 12 dB sign add point in the analog world. It's what our system is radio is going to be rated for. So let's go ahead and get that going. Let me come over here and turn on the pattern here, and you can see you can hear the tone coming in, and I'm going to go over to my radio here and go ahead and start. And it muted the audio for me, and you can see up on my radio here it's giving me an indication. So what I'm going to do is I'm going to go up to the RF level, and I'm going to turn it down until I start seeing the errors, and when we get to 5%, whatever level that is, that'll be the official receive point for that radio. So let me get on here and start turning down the level and see if we can't start generating some errors here. There, we just started, and you see the bit error rate is just starting to wake up there and flicker, and we're coming down, and we'll go one more here, somewhere around there. It's hovering right there. You can see it's in a tricky spot, but that's a minus 122. The official level is minus 121, and we're making it. We're somewhere around 4 plus there. We're barely hitting 5. So that would be an indication of a good radio receiver, and it would pass the spec as far as its ability to decode the zeros and ones, even with a really weak RF signal. And you can see the curve is really sharp here. I don't have to come up to, what's that, about minus 113 there, and I'm already back to kind of perfection, 114. So that's the kind of the nature of the digital radios here, is that they're perfect all the way to the very edge, and then they roll off really quickly and stop. But anyway, yep, there's your bit error rate test for your BK, and like I said, it's working out fantastic. So let me turn it back up here. As a matter of fact, see if I can go up here and just go off altogether. And this is what I wanted to show you, was the bit error rate with absolutely nothing is 50%. So that shows you it's a complete, just absolutely is decoding nothing. I know you should think it would be 100%, but it's 50%. But anyway, that's the bit error rate test. We can look at a couple other things while we're here, just so you can see what they look like. We got a calibration pattern, and let me stop the test here. And we also have a silence pattern as well, and you can test those out for yourself. They're kind of neat. But anyway, yeah. So that's your basic P25 receive test, and I'm going to do another video on the transmit. So hope that helps, and we'll talk to you soon.